Math 230, Quest to College. I'm Joe Vasta, and we are covering section 6.7. This is called More Combinations. And so we will be doing more combinations here, whatever that means. But before we do that, I'm going to give you two puzzles here. The first puzzle, we have some triangles and some numbers. So what is question mark? So you have to figure out what question mark is on that one. And then the second one, same kind of problem. What is question mark? So you have some triangles. You can pause the video and see if you can figure out what that question mark is. More combinations. So make sure you get your Pascal's triangle ready. We're going to see what we can do on this. How many different three-person committees can be selected from a group of 7 people? Okay, so we can draw the 7 X's, circle 3 of them, and see that really there's not different labels when I'm circling them. It's just a 3-person committee. So this is just a basic combination. This is going to be 7 choose 3. Where am I going to find 7 choose 3? Right here on Pascal's triangle. Here's row 7. 1, 2, 3. 35. Okay, let's continue. How many different committees consisting of at least 3 people can be selected from a group of 7 people? So now we have this. It says at least 3 people. How are we supposed to do this? How many different committees consisting of at least 3 people can be selected from a group of 7 people? So at least 3 people means 3 people or more. So if I have at least $20, it means I have $20 or more. So at least 3 people could be 3 people for the committee, or 4 people, or 5 people, or 6 people, or 7 people. Now why do I have to stop at 7? Because we're selecting them from a group of 7 people. So these break up into little problems. And you may have remembered when we were doing something earlier in this section, I wrote OR down and those ORs became pluses. So what I want to do is I want to count all the committees that have exactly 3 people in it. And the way to do that using combination talk or choose talk would be 7 choose 3. Or, so that's a plus. Now I break it down to this one. How many committees can we have from 7 people with exactly 4 people? Well, that would be 7 choose 4. Or, that's a plus. 5 people, that'd be 7 choose 5. Or 6 people, 7 choose 6. Or 7 people, 7 choose 7. So this is the first time we've ever done anything like this with combinations. And we're going to add them up. Well, look what happens when we add up the combinations. This is 7 choose 3 plus 7 choose 4. Let's move this up here so it looks like this. Let's see if I can look at, oh, there's row 7. Row 7's right here. So 7 choose 3. 1, 2, 3. That's 35. And 7 choose 4 is 35. And 7 choose 5 is 21. And 7 choose 6 is 7. Such high tech. 7 choose 7 I'm running out of pins here. I have a pin. It's that guy right there. So I have to add up those numbers. And this is why Pascal's triangle is really good, because we wouldn't want to compute these guys using that combinations formula. We'll reserve that combinations formula for combinations that have larger numbers where we don't want to use Pascal's triangle or compute it. So this is 35 plus 35 plus 21, that's 7 choose 5, plus 7 plus 7 choose 7 is 1. So I get those numbers right from row 7 in Pascal's triangle. So now I have to add this up. That's going to be 70, 80, 90, 91 plus 8 is 99. And that's how I do these problems that say at least. And this one's going to say at most. So we'll underline that. How many different committees consisting of at most 3 people can be selected from a group of 7 people? Well, if I have at most $20, I have $20 or less. So at most 3 people is 3 people or less. So I can have 0 people or 1 person or 2 people or 3 people. So now I do these problems. It's going to break up into 4 individual problems. How many ways can I select 0 people from 7 people using combinations? It's going to be 7 choose 0. Plus committees with just 1 people, 7 choose 1, plus this one is 7 choose 2 plus 7 choose 3. So now we're going to go up here. And I have some explaining to do why I used blue ink on some of them. I'm going to go to row 7. So we can get a little bit closer like this. Okay, so there's row 6. And make sure that everything's in view. So this is 7 choose 0. 7 choose 1, 7 choose 2, 7 choose 3. So let's write out the number. 7 choose 1 is 1 plus, that was my only blue pin there. 7 choose 1, that's 7. 7 choose 2 is 21. 7 choose 3 is 35. Okay, so what do we make of this? Well, here's the deal. If you add up those numbers, you end up getting something like 35, 56, 57, 58, 59, 63, 64. You end up getting 64. Now, some of you would feel uncomfortable with that because you would think, well, Joe, you cannot have a committee that has 0 people on it. So you're not going to add that one. And so some of you would say, well, I feel more comfortable putting 63 as the answer. So this will be the one time in this class where I would accept either answer for this particular kind of problem. So this 64, this is if you count the empty, the empty committee. or the committee that has 0 people on it. And you might say, well, Joe, that is dumb. Well, I've been on committees here at Cuesta College, and I've seen sometimes more stuff would get done if nobody was on the committee. So I would accept either one. Now, there's an advantage of doing this blue way, is when we start flipping coins and doing some other things, you have to absolutely count the thing that is choose 0. So when we're flipping coins, and we will get to those, and it's at most problem, you absolutely have to count that. So, you know, if I'm accepting either one, you might as well just go all the way down to 1 on all the kinds of problems that have at most on it. But some of you won't feel comfortable with that, and you'll put 63 for a problem like this. That's all right. So this completes the first 3 problems. The next 3 problems are going to be very similar, and it might not be the worst idea for you, you know, it might not be a bad idea for you to pause the video and see if you can do these on your own. You'll be using Pascal's triangle, you'll be adding some combinations on some of them, okay? So there it is. So here's the problem. Flip a coin 6 times. How many different ways can the outcome have exactly 2 heads? Well, you see that this happens to be 6 choose 2. 6 choose 2 on Pascal's triangle. You go to row 6. You count over 2. 1, 2. 15 is the answer. Flip a coin 6 times. How many different ways can the outcome have at most 2 heads? So here's the word, or the words at most. Okay? We'll underline the 2 heads as well. So what does at most 2 heads mean? It means 2 heads or less. So what it means is, it means 0 heads, or 1 heads, or 2 heads. So these become 3 different problems, which I'll add the answers together. So 0 heads would be 6 choose 0, which you absolutely have to have that one in this kind of problem here, because that can happen. You can flip a coin 6 times and get 0 heads or all tails. That is possible. Now, you can argue that a committee that has no members is not really a committee. I'll accept that on problem number 3, but this one you need to put this plus. Here's 1 head, 6 choose 1, plus 6 choose 2. So this all comes down to Pascal's triangle. Which row? Row 6. 6 choose 0. 6 choose 1. Hopefully in the camera though you can see that that's what it's pointing to. And 6 choose 2, which is that guy right there, which is the 15. Okay, so it looks like I have 1 plus 6 plus 15. 21, 22. This adds up to 22. There are 22 ways that this can happen. Okay, so problem number 6. Flip a coin 6 times. How many different ways can the outcome have at least 2 heads? At least 2 heads. Well, at least 2 heads means 2 heads or more. 2 heads or more would be, let me just make it going all the way across. 2 heads, or 3 heads, or 4 heads, or 5 heads, or 6 heads. So that's a lot of problems to do. This one, this one, this one, this one, and this one. Okay, well anyway, let's continue. 2 heads would be 6 choose 2. 4 is a plus. 3 heads would be 6 choose 3. And when I'm doing this, it just means I'm doing this problem that says you flip a coin 6 times, how many ways can you have exactly 3 heads? Well, it would be 6 choose 3. Okay, but because this says at least 2 heads, we have to add up a whole bunch of cases. Plus 4 heads, this would be 6 choose 4. Plus 5 heads, 6 choose 5. Plus 6 heads, which is 6 choose 6. Okay. I don't even know if I have that many pins. Let's see, that's... Well, maybe I do, because then I... Oh, no. We're pushing this to the limit here. Which is a mathy thing to say. 6 choose 2. So here's row 6. 1, 2. 6 choose 3. 6 choose 4. Yeah, I think I did have enough pins. 6 choose 5. 6 choose 6. So this is going to be 15 plus 20 plus 15 plus 6 plus 1. So what do we have here? We have 20, and then those 15s make 30. So let's see, 20 plus 30 is 50. And we have 7 there, so this is 57. Before we move on to the next problem, I want to show you that what a statistics teacher might do if you have to take a statistics class. Okay, so I'm going to show you something. Row 6 on Pascal's triangle looks like this. This is like a 1, 6, 15, 20, 15, 6, 1. Now remember when we first did Pascal's triangle, I may have said this in a lecture. The row of any Pascal's triangle adds up, gives you a sum of 2 to the row number, 2 to the 6th. So like if we were adding up row 7, it would be 2 to the 7th. So once again, this is optional, but if you are heading into a statistics class, sometimes they'll do this. And so 2 to the 6th happens to be 64, because it's 8 times 8, 64. And in this problem, what we wanted to do, you know, what you had right there, I'll underline these in yellow, is you had to add those up. And for some of you, this may be more confusing than just doing the problem directly. So some statistics teachers would say, well, why don't we just go like 2 to the 6th minus the things that we're not supposed to add up, minus 7. And so 2 to the 6th we said was 64 minus 7. And that gives us 57. Now the reason they might do something like this is because in a statistics class sometimes they say, oh, we're going to flip a coin like not 6 times but 20 times. And then they might say, what is the probability that the outcome can have at least 2 heads or at least 1 head? And then instead of adding up 18 things, you could just say the sum of the whole row minus off the stuff that wasn't on there. Now, you shouldn't really need to know how to do that to do your homework or the test in this class, but this is just a warning for people taking statistics. And you've been warned. Let's go ahead and do some more problems. There's a few other skills we have to know for 6.7. Here's the next one right here. A class contains 4 boys. Did I say 4? A class contains 5 boys and 7 girls. How many ways are there to form a 6-class member committee consisting of 4 boys and 2 girls? Oh, that's where I was getting that from. Wow, so this is crazy. Crazy, 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 isn't it? So what we want to do is go back to 6.1 and try to do skills from there. And you're like thinking, what? How many tasks do we have to perform? You have to, you're getting a 6-class member committee, but you want to choose 4 boys from 5 boys. So you want to choose boys first. Then your next task is to choose, or we were calling them events, and that's alright, 2 girls. So you want to choose the girls. Okay, so underneath we'd like put the ways. Now, back in section 6.1, we might say the class consists of 5 boys and 7 girls, and 6.1 would say how many ways are there to form a committee consisting of 1 boy and 1 girl, and then you would go 5 times 7. So you might have remembered that. And the same thing with the pot holders and the ornaments. And if you don't know what I'm talking about, that means you probably didn't watch that video. You were just picking 1 pot holder and 1 ornament. Now we're picking out more than 1 of each of these. And when you do that, we just break this down into some problems here. It says 4 boys from 5 boys. Well, that's a combination because we're not like saying that they have to be president, vice president, secretary, you know, stuff like that. We're saying let's go ahead and go 5, choose 4. And that's how many ways we can select those 4 boys from the 5 boys. Well, the same thing with the girls. To select the 2 girls from the 7 girls, this is a combination. We're going to go 7, choose 2. And because these are 2 different events, we do this first, we do that next, we multiply them together. Now, if you're going, oh man, in the last few problems, we were adding them. When we were adding them, you'll know in this class, we add these when we see the at least, at most, and then when we get a problem like this, we are multiplying them. So we'll get some practice here. 5, choose 4. 1, 2, 3, 4. That's 5. Multiplied by 7, choose 2. 21. So we used Pascal's triangle to get that. What is 5 times 21? That happens to be 105. So there's 105 ways of doing this. You know, maybe you're a poker player and instead of boys and girls, you have like 4 things you're interested in: hearts, diamonds, spades, clubs, and you're trying to figure out your 3 of a kinds or your 2 pairs or your full houses. You're doing the same thing. It's just a little bit more complicated. Let's go ahead and do problem number 8. Maybe you can pause the video and do this one on your own. It's very similar. Okay, problem 8. So, you know, I'm going to go ahead and put a slot for the boys and then a slot for the girls, because what am I doing? Well, it's pretty much the same problem. You have 4 boys. There I go again, saying 4 boys. What is up with that? 10 boys and 8 girls. How many ways are there to form a 5-club member committee consisting of 2 boys and 3 girls? Notice we'll never use that 5 because those guys add up to 5, just like the 4 and the 2 add up to 6 up there. So what you want to do is choose your boys. How many ways can you choose 2 boys from 10 boys? Well, it would be 10 choose 2. Multiplied by, now we choose the girls. 8, choose 3. So looking at Pascal's triangle, I know we keep showing you Pascal's triangle, but that's a lot of the combinations here. 10 choose 2 is 45. Multiplied by 8 choose 3, 56. So I'm going to go 56 times 45. So 30, carry the 3, 25, 28. Okay, we have a placeholder 0, and then we have 24, carry the 2. 20, 21, 22. We add those together. So I have 0, 12, carry the 1, 5, 2. Wow. So I get 2,520 for the answer on this one. And there it is. So in problems 7 and 8, we are multiplying combinations. And in this class, you'll add combinations only when you see the at least or at most problems. Now, in the real world, things can get more complicated, but you know, this is just an introduction to counting. Okay, some more problems here. A certain club has 4 seniors, 7 juniors, 6 freshmen. How many ways are there to form an 8 club member committee consisting of 3 seniors, 1 junior, 4 freshmen? Now, in the last 2 problems, people were partitioned into 2 groups. Now, this problem, they're partitioned into 3 groups: seniors, juniors, freshmen. So there are 3 events or 3 tasks I have to do. I have to pick the senior, and then the junior, and then the freshman group. Okay, so 4 seniors, we want to choose 3 seniors. So in choose talk, that is 4 choose 3. Okay, we're doing slots here, so this is going to be multiplied by. Now I'm going to choose the juniors. 7 juniors, choose 1. And then we multiply that by the freshman selection. 6 freshmen, choose 4 of them. 6 choose 4. And then what are we going to do with that? Well, we're going to go to Pascal's triangle. 4 choose 3. That's a 4. The next one is 7 choose 1. And the last one is 6 choose 4. That's 15. So we come back down here. The way I'm going to multiply, I'm going to go 4 times 15. That gives me 60 times 7. So really, I just have to go 7 times 6, which is 42. So the answer here is 420. Next problem. The next problem says, a bookshelf contains 5 different science books, 6 different art books, 7 different history books, and 8 different math books. How many ways can you select 4 science books, 3 art books, 1 history book, and 5 math books to donate to the school library? Once again, if this 4 had been a 1, and that 3 had been a 1, and that 5 had been a 1, and there's already a 1 there, this would have been a problem from 6.1. But it's not, so I'm going to go ahead and put 4 slots. Why? Because now there are 4 groups of things. We have science books, art books, history books, math books. Okay, so for science books we have 5 choose 4. Multiplied by 6 art books, choose 3. multiplied by history books. 7, choose 1. And then math books. 8, choose 5. We turn this over to Pascal's triangle. 5, choose 4 is 5. 6, choose 3 is 20. So that's good news. The 5 times the 20 is going to be pretty sweet to multiply out. 7, choose 1. In fact, you might be getting used to anytime you have like a number choose 1, it's going to be that number because it appears on that diagonal. And 8, choose 5. 56. So I'll multiply it like that. 5 times 20 is 100. That's going to be pretty simple to do. And then 56 times 7. See, 42, carry the 4, 35, 39. So this is 392. So I go 392 times 100 is 392 with 2 zeros. That's how you multiply something by 100. So I'll put the comma there. 39,200 ways that this can be done. So we have that there. That is problem number 10. So now what we're going to turn this over to is the rest is just a little bit extra. Some of you are going to find these next few problems very interesting, and some of you might want to just skip ahead to the puzzles and be done with this lecture. So problem number 11, this is an extra credit caliber problem, and it says a family has 9 kids. A group of 2 is to rake leaves, a group of 3 is to pick up dog poop, and a group of 4 is to wash the car. How many ways can the groups be formed? So look what we have here. We have the 9 kids. Whereas 2 of them are to rake leaves. And 3 are to pick up dog poop. And the other 4 wash the car. So back in the day when we first were doing combinations in 6.6 and we introduced this notation, we saw that like combinations partitioned this group of people into 2 groups. Well, here's the first time where we're partitioning this into 3 groups. So that's the picture I want to show, because the picture I'm going to make over here, I'm going to destroy it as I do the problem. So here's the 9 kids. 1, 2, 3, 4, 5, 6, 7, 8, 9. And so if the problem just said a group of 2 is to rake leaves, and you're like, okay, you're going to rake leaves, and you're going to rake leaves, how many ways can that happen? Then you would say, oh, well, this is just going to be 9, choose 2. Okay. But this problem has a little more than that. Those kids rake leaves, they're gone. Okay, they're like, okay, let's go rake leaves. And so now how many kids do you have standing here waiting for their assignments? 7. And so now the problem continues. A group of 3 is to pick up dog poop. So you've got to select those 3 to pick up dog poop. And you know, maybe you're like, okay, you're going to pick up dog poop. And maybe they were the bad kids. You know, you were fighting with your brother, dog poop. Dog poop. And you have to pick it up with your hands. I don't know what's happening in the story. Actually, it doesn't say all the psychological aspects of this. But those guys are picking up dog poop. How many ways can you select 3 from 7 to pick up dog poop? Well, it would be 7 choose 3. And so they're out as well. You know, maybe as they're leaving, they're like, so long, farewell, or not. And if only one person got that reference, then it was all worth it. So you're pretty much done with the problem. This is a multiply because your first task was to assign 2 to rake leaves. Your second task was assigned 3 to pick up dog poop. And by default, what are those 4 guys doing? They are washing the car. Now, I'm going to do something that might bug some people, but how many ways can you select 4 people from a group of 4 people? Well, 4 choose 4. 4 choose 4, we know is just 1, so that's really unnecessary. Now, I'm going to show you something kind of cool. Let's write all these out, not using Pascal's triangle. Look at this. 9 choose 2, 9 factorial on the top. 2 factorial on the bottom times 7 factorial. That's that formula that we derived a few sections ago. Multiplied by 7 choose 3, 7 factorial on the top. On the bottom you have 3 factorial, and then those have to add up to 7, so 4 factorial. Multiplied by 4 choose 4. You have 4 factorial on the top. This one's kind of dumb. And then on the bottom you have 4 factorial, and then you have a 0 factorial. So look what happens, and there was a reason I did this even though this was unnecessary, because look, the 7 factorials cancel, the 4 factorials cancel, and we know that this right here is 1. So what does this thing become? This thing becomes, what's on the top? 9 factorial all over 2 factorial, 3 factorial, 4 factorial. What do those guys on the bottom add up to? They add up to 9. This probably reminds you of these combination formulas, except now we've partitioned the group into 3 groups. And so this has notation. Some books will say the notation for this is we have 9 up there, 2, 3, 4. Wow, this is kind of a hybrid between combinations and permutations. Yeah, these are definitely combinations, but you can see there's 3 different labels happening now. You know, that you've got the rake leaves, the pick up poop, and the wash the car. So this is sort of a hybrid between permutations and combinations. And so how would you do this? You'd write them all out, and I mean, I'm not going to concentrate on that. You know, you'd go 9, 8, 7, 6, 5, 4 factorial, cancel the 4 factorials, and then let me just do it, okay? Sorry about that. 9, 8, 7, 6, 5, 4 factorial. Then you have a 4 factorial there, and then 3 factorial is 6, and then 2 factorial is 2. So the 4 factorials would cancel, the 6s would cancel, the 8 would cancel with the 2, so this is a 4. Those are all 1s. And you would end up going 9 times 4 times 7 times 5, which is actually 1,260. I prepared that answer ahead of time. Okay, so let's go ahead and do this. A similar kind of problem. Look, it's the same thing, except the family now has 12 kids. Wow. And we're going to see if we can kind of jump to this formula and not have to write this out. The multinomial coefficients. Sometimes that's what this is called. And so you have 12 kids. 5 have to clean the house. 3 have to clean the barn. 2 have to clean the outhouse. and 2 have to paint the fence. And you can see that those guys there, 8, 9, 10, 11, 12, they add up to make up for the 12 kids. So how would you do this problem? You'd go 12 factorial over 5 factorial, 3 factorial, 2 factorial, 2 factorial. And then, of course, you can write this out so it's 12, 11, 10, 9, 8, 7, 6, 5 factorial, cancel the 5 factorials, and do the work on it. The point is, we now have this really cool notation when you're breaking a group up into more than 2 groups. You know, it used to be, you know, we have 10 people and we need 3 to serve on a committee. Well, now we have like 12 people and we need 5 to go there, and 3 to go there, and 2 to go there, and 2 to go there. So what we end up having for our answer is 23,760. Once again, I would not worry about these for the exam. This is just a little extra bonus. Our last one. I wanted to come back to this because we talked about this in the previous section. A math teacher with a class of 10 students wants to give 3 F's, 1 D, 1 C, 3 B's, and 2 A's. And, you know, if you add them up, it adds up to 10. How many ways can he do this? Well, what we're doing then is we have 10 students, 3, 1, 1, 3, 2. And so this is really, maybe we don't even need to write this part. This is 10 factorial. And then what do we have? We have 3 factorial, 1 factorial, 1 factorial, 3 factorial, 2 factorial. I'm going to go ahead and compute this one out by hand then. Well, I think I'm going to. I might change my mind. 8, 7, 6, 5, 4. Here's a 3 factorial. That's what 10 factorial is. And then I have a 3 factorial. These 1 factorials I'm going to leave off. So those guys are going to cancel. And then this 3 factorial is 6, which will cancel with the 6. And then we have a 2 there. So that's out of there. The 6 is out of there. And then we have the 2 and the 4 cancel, so we have a 2 there and a 1 there. So everywhere else is 1s that went away completely. I have 9 times 8 times 7. That's 504. We've seen that come up a few times. And then 5 times 2 is 10, and then you have another 10, so you're really multiplying it by 100. So there are 50,400 ways that you can do this. So this completes this section, and I believe what I want to do is I want to include in the PDF counting poker hands. So for those of you who are interested in that, and there's some combinations there, I know the font there is really small. Before we leave, we must get to these puzzles. Okay, so our first puzzle that was given is, what is question mark? I was actually going to say, what is question mark with a question mark behind that, but then that would have confused people. So I can't put a question mark at the end of this question because, anyway, I'll stop talking. How do we get the number that goes there? Well, on this one, some of you are going to hate me for saying this, is you take the difference between 7 and 4. That difference is 3. And the difference between that, which is 6. 7 minus 1 is 6, and a 4 minus 1 is 3. So 6 plus 3 plus 3 is 12. And so that's how you do it. So this one has a difference of 2, this has a difference of 1, and 1. Those red numbers add up to 4. 4 and, what is that? 4 and 8. Those guys add up to 16. So let's see what question mark is. This has a difference of 1, difference of 3, difference of 4. 4 plus 3 plus 1 is 8. 8 is the answer to that puzzle. The next puzzle, what is question mark? You know, so it's going to be different. It's not going to be adding up the differences. what we're going to do on something like this is let's add up these numbers. This is like 16. 9 plus 7 is 16, plus 5 is 21. So that adds up to 21, 18, 19, 20. So this is 26. And then these guys add up to, let's see, 14. Those guys add up to 15. Okay, so those are the sums. What do you notice about 21 and 12 and 26 and 62 and 14 and 41? Well, what we've done is we reversed the digits. So what is question mark? It is 51. Okay, so that completes section 6.7. Do your homework. Have a good day. I'll see you in the next video.